Hi guys, last note of the unit. This is called Exploring Operations with Functions. And what we're going to learn today is we're going to learn what happens when two functions are either added or subtracted together, or what happens when you take two functions and actually multiply them together. Not sure what's happening here. Sorry about that, guys. Oh, is that making you dizzy? It's like doing the opposite of what I wanted to do. Okay, well, if two functions have domains that overlap, they can be added, subtracted, or multiplied to create a new function on that shared domain. So, for example, if we have, let's say, g at x equals 3x plus 1, and f at x equals root x, we can create a new function, h at x, where we add them together. So we would have 3x plus 1 plus root x. Okay, so the domain of g at x is any real number. And the domain of this is just x greater than 0. So where do they overlap? Well, they overlap in the domain x is greater than 0. So this is have a domain x is greater than 0. Okay, now you can find the y values of this new function two ways. Either you can just put an x value into this function and see what it spits out, or you can put that x value into this function and into this function and add the two results together. That's the same thing. Okay, so you just add or subtract the y values from each individual function. Now this could also be written as this, f plus g in brackets at x is addition, or f minus g at x would be subtraction. You have to have the brackets around the f plus g to show that they both are operating on x. Okay, so you could just add the y values from f at x plus the y values from g at x. Okay, or subtract. All right, now for multiplication, guess what? It's the same thing, it's just that you're multiplying. So this could be rewritten as, notice they use a dot there for multiplication instead of a cross, that's important. It could also be written as f times g at x like this. Okay, so you just multiply the y values. So you find the y values from f at x and the y values for g at x, and then you multiply them together to get the y values for h at x. So if you have these two linear functions, what do you do to add them together? Well, this should be g. Well, literally, then you just have h at x, so you have f at x is 3x plus 4. Okay. And then we have 4x minus 5. I'm just putting brackets around them to show the separation. But because it's addition, you just flat out add. So you just get 7x minus 1. So to find the y values, again, either you just put them into this function and get out your y values, or you put them here and here and then add them together to get the y values. Example 2. Okay, this is just a graphical example. So what if you have a function, a linear function here? So let's say we have this plus this. Okay, this is our line. So I can go here to make a line. So that's function 1. And then function 2, say it's here. Okay, what would happen? Looks kind of funny. Okay, what would happen if I add these two together? So notice that this black line exists it looks like forever, okay, or from these points, but the blue one only exists from here to here. So we can only add the points where they overlap. So here I can add these two. So I have this point plus 1, so I add them together and I get a coordinate up here. And then here I have 1, 2 plus 1, 2, 3, 4, 5. So that's going to give me 7. So also up here. And then I have 1, 2, 3 plus 4. Sorry, this one, let me recount these. Okay, this is 1 plus 1, 2, 3, 4, 5, 6. So that gives me 7. This is 1, 2 plus 1, 2, 3, 4, 5. Wait, how do these all give me 7? One, 2, 3, plus 1, 2, 3, 4. These are all giving me a line of 7. This is weird. Okay, 1, 2, 1, 2, 3, 4, 5. So this is somehow giving me a perfectly straight line of 7, which is kind of strange. Okay, and that is just the black. So this is F, and this is G. That is just F plus G. Okay, and so we would, sorry, I shouldn't have put those, let's erase. We don't want these arrows here because we only want to include it for the shared domain. So here's where it starts. And it'll end here at this point because that's the last point where they have the shared domain. Okay, so what about if we want to do F times G? Well, this is 1 times 6, so we have this coordinate here, 6. Then we'd have 2 times 5, so we'd have a coordinate way up here at 10. Then we would have 3 times 4, so you'd have a coordinate up here at 12. So this isn't a great example to do multiplication. So let's do a different one, just because these numbers are getting too high. So let me create a different function down here. Okay, so this is going to be our line down here. Okay, so now we're going to add together the black one and the purple one. Sorry, multiply them together. So this is a 0 times 2, so you would just get 0. Okay, you're looking at the y values. Here it's a 1 times a 1, so you'd still get 1. Here it's 0 times 2, so you'd get 0. Here it's 1, 2, 3 times negative 1, so you'd get negative 3. 1, 2, 3. And here you get 1, 2, 3, 4 times negative 2, so you'd get negative 8. 1, 2, 3, 4, 5, 6, 7, 8. So notice that this is a parabolic shape. Okay, so this is F times, we'll call this H. H. Now, think about why it makes sense that a linear times a linear would give you a quadratic. Okay, that's because when you're multiplying something with an x in it, plus whatever number, and you're multiplying something else with an x in it times whatever number, your result will include an x squared plus whatever x's plus whatever numbers. Okay, so when you combine functions, these are the things to think about. All right, so that's just a very brief introduction into the world of operations with functions, but you can play around with it some more. You can also go into GeoGebra and play with it there too. You can create two functions and add them or subtract them or multiply them, and we'll try maybe some more of that tomorrow. Okay, thanks for watching, guys. Hope you learned lots.